Okay, 2.3, we're going to go through a whole bunch of postulates, and you really do need to focus on these. They can be confusing, so just like inductive reasoning and deductive reasoning, you're going to confuse the two, and there's a whole bunch of these that you can confuse. Not only that, but we start to get into some of these things where you're like, this doesn't make any sense. In general, each individual one is very simple. But this is where you're going to start messing up on the test. So pay attention, okay? And as we progress, it'll make a little more sense. You only got 10 problems for homework tonight. But that doesn't mean that's enough for you to remember things. You're going to have to do some things on your own to remember this stuff. Okay? So you have to memorize some things. All right, 2.1, the 2-point postulate. Number one, the number 2 stands for the chapter. And number 1 is the postulate, first postulate, okay, in this section. So don't label these by saying, oh, that's postulate 2.1. I'm going to count it wrong, because in another math book, it might be in a different chapter and have a different number. So you have to go by the name. 2-point postulate says this: through any 2 points, there exists exactly one line. Before today, I couldn't say, oh, there's a line AB. No, because there's no line there. Before, you could not say that. So remember on the test and stuff I said, or throughout all of chapter 1, I said, you got to make sure it's in the picture. If it's not in the picture, you cannot assume. This is why. Now, if it's something like that, you can go ahead and say, oh, I know there's a line that goes between those, that goes through those 2 points, the 2-point postulate. Okay? All right. So the next one, line point postulate. A line contains at least 2 points. So before, if I drew a line and said that's line L, and you guys say, oh, there's 2 points on there. And no, you learned that you could not say that. But now, if you see a line and there aren't any points on it, you can say that you know there's at least 2 points because of the line point postulate. So you have to give a reason for what you're saying. You can't just say, oh, because of that thing. I know there's 2 points on that line. You have to say why, how you know that. You have to give me the name. You're going to have to know the theorems. You have to know the definitions. Okay? You can't just write out a reason. You have to give me the name of the postulate. 2.3, line intersection postulate. This is pretty simple. If 2 lines intersect, they intersect in a point. Before, if there wasn't a point there, you couldn't say that there was a point. You couldn't use it as a point. Now, if there's no point listed, you can give it a point and say that you have the line intersection postulate. Okay? Catching on? All right. The 3-point postulate. Through any 3, and this is important, non-collinear points. This is why I told you before, if you're going to use 3 points, you better be talking about a plane. If you're going to use 2 points, it better be only for a segment or a ray or a line. And I told you on the first chapter that if you chose to label a plane with 3 collinear points, I would accept it, but you shouldn't do that. Okay? So they're saying it needs to be collinear, so from now on, make sure it's non-collinear. Through any 3 non-collinear points, there exists exactly one plane. All right, so if I gave you 3 points, then you can go ahead and say, oh, well, I know those 3 points are inside one plane somewhere. Or there's a plane that encompasses those. And then 2.5, plane point postulate. A plane contains at least 3 non-collinear points. So if I draw a plane and call this plane P, and there are no points in it, you now can say, well, yes, there's at least 3 points in that plane. Okay, let's go on. 2.6, plane line postulate. If 2 points lie on a plane, then the line containing them lies in the plane. All right, so what they're saying in this picture they gave us, there are 2 points that are in the plane, and through those 2 points you have a line. Well, if the 2 points are in the plane, then the line has to be in the plane. That's what that's saying. Plane intersection postulate. We talked about this. We've already discussed this many times. If you have 2 planes intersecting, like the floor and the wall, there's a straight line that is made. Before, if it wasn't labeled, you couldn't say it. Now, if it's not labeled, you can say, well, yeah, I'm going to label it because of this postulate, okay? The plane intersection postulate. All right, so keep those close by. And let's take a look at the extra practice. Now, number 1 is kind of confusing because they give you 3 points. And then they drew a line through the 3 points, so they're collinear. So you have to interpret what it is they're saying. So if there are 2 points, then there exists a line that goes through those 2 points. What postulate is that? Look at your postulates. Which one is it? Yeah, it's the line point postulate, or 2 point postulate, sorry. Through any 2 points, there exists a line, right? So that's the other thing. You got to make sure you get which one it is. Number 2, look at both of those and see if you can decipher what they're saying. And the first one, you have plane S, and there are 3 non-collinear points in it. And then it says, oh, in that plane, oh, there's a line that goes through 2 of those points. So which postulate do you think that is? You have 2 points, M and N, that are in a plane. So therefore, there must be a line that goes through those points, and it's in the plane. So it's that postulate that you would label. Okay, next one. 2-point postulate. Somebody read me the 2-point postulate. There's on.
Through any 2 points, there exists exactly one line.
Through any 2 points, there exists exactly one line. Now, before, you would automatically say, oh, that's line L or line BC. And that's totally okay. You can say that. The better answer that they're wanting here is really line AB or line AC. Because there's no line drawn, but you know that there's a line there. That's what they're talking about. But you could say line BC. You know there's a line between A and B, through A and B, and through A and C. Now, somebody else read me line point postulate. What's the line point postulate?
A line contains at least 2 points.
Okay, and before you would say, oh, line L, because line L contains 2 points. But now you can also say line K, even though there's only 1 point labeled on it. Because it's a line, you know there's at least 2 points on it. So either one of those is fine, but for this section, the more appropriate one is line K. Now, somebody else read me the plane point postulate.
If 2 lines intersect, then their intersection is exactly one point.
Did I say line? Plane point. Plane point.
Plane contains at least 3 non-collinear points.
Yep. A plane contains at least 3 non-collinear points. Well, you have A, B, and C in plane P. That's already labeled. But we also know, based on that postulate, that in plane Q, there has to be at least 3 non-collinear points as well. Okay? And somebody else read me the plane intersection postulate. Yeah. So we've already known this, and now it's, even if it wasn't labeled, you could label it. So plane P and plane Q intersect at line K. That's what you would say. Plane P and plane Q intersect at line K. That is the plane intersection postulate. Now we'll skip 7 and 8. You can draw all that stuff in your homework. Let's go ahead and look at 9. Now, this is asking, can you assume? Which we've already been learning that you can't assume things. So really the correct question is, can you prove it? So planes A and B. Planes A and B. Do they intersect at line EF? Yes or no? It's not a trick question. Yes, they do. All right. Points C and D are collinear. Yes or no? I'm just curious. Everybody else, what do you think? Hello? Yes or no?
Yes.
What about you girls?
Yeah.
Yes. How do you know that? How do you know that CD are on the same line? The answer is yes, so tell me what postulate that is. 2-point postulate. Is there any 2 points there exist a line? Catching on to what you're really doing? This is truly what the class is all about. Don't worry, we're still going to do some math. But we got to get you in understanding how to prove things, okay? Ray HJ, okay, I'm going to draw this. Ray HJ is perpendicular to line ID. Is that true? How do you know?
Intersects at like H.
Intersects at H at 90 degrees. So that's the definition of perpendicular lines. Okay, perpendicular has a definition that 2 lines intersect at 90 degrees. And this is the symbol for perpendicular. So if you see that in your instructions, you therefore know by definition, you would say this in your proofs, by definition of perpendicular lines, these are equal to, the angle is equal to 90 degrees. Okay? Again, you haven't done proofs yet? I'm planting the seed. Line GD. Line GD is this line right here. Is a bisector of line EF. Yes or no? At point D. Yes or no? Is line GD a bisector? Who doesn't know? So you all know. You don't know. Okay. Who else? Anybody else not know if it's yes or no? So what's the definition of a bisector?
A line that divides another line.
Something that divides something else into 2 equal parts. Could be an angle, right? So here we have line GD. What are these little things? What did I circle up there? What are those little things? Those marks. What do they mean?
They identify that there's a bisector, that they're equal.
Yeah, so ED is the same as DF. Well, that's where that line intersects that segment at. So yes, because of those hash marks, we know that GD bisects EF. All right, let's make it a little harder. Segment IH, this segment right here, is that the same as HG? Are those two the same segments? Can you assume that they are, yes or no? So if they're the same, would there be hash marks? Are there hash marks? And in your instructions, if they're telling you they're the same, you can put the hash marks in. So you'll be doing that on your pictures based on what's been given. But nothing's been given, so you cannot assume those two are the same. All right, let's look at this angle. HJD. This angle right here they're wanting to know, is it complementary to this angle over here? What's complementary mean? What's complementary mean? They add up to 90. So do they add up to 90? How do you know? Okay, so what's that square mean? So this is a right angle here. What's that have to do with those other angles?
The right angle already is 90, so if you add something else to it, it can't equal 90.
Okay, so watch. They are complementary. Watch. How many degrees are in a triangle? So look at this triangle. That triangle, one of the angles is 90. So this angle right here, H, is 90. Oops. So if H is 90, then angle J and angle, whatever it is, D, they have to add up to 90 to be equal 180, don't they? So by definition of complementary angles, they're complementary, okay? Does everybody see that they have to be equal to 90? Now, they don't have to be equal to each other. They have to add up to 90. So we don't know that they're congruent. That's not what it's asking. It just says, are they complementary? So they have to in a triangle. If the other angle is 90, then those two have to add up to 90 to be equal to 180. So yes, you can assume those two are complementary. Welcome to geometry. All right, so your homework is on Google Classroom. You got 10 problems or something like that. You probably could get it done in about 12 minutes.